ladies and gentlemen, come one, come all, welcome to the 2022 Electromagnetic Universe World Expo. Today we have our guest, Robert Ashcroft. Robert Ashcroft has a Bachelor of Applied Science, Computer Science, various fields in computing, as a career culminating in data architect for Australian government agency. Primarily involved in documenting data standards and business modeling for development of automated systems. Now semi-retired, examining basics physics from 2014 and examining the fundamental basic building blocks to produce our universe.
Okay. Oersted in 1920 discovered that if you have a magnet near an operating electric circuit with copper wire and so on, the magnet deflects. And he wrote a short publication in Latin and sent it out amongst all the people who are curious about new things. And Argo demonstrated this result to the Academy of Sciences in Paris. And at the time, Ampere was there. That's how Ampere discovered it. It was a shock to him. And he went away and studied electromagnetics for 7 years. And at the time of this experiment, and in the time period that Ampere was working on his experiments, Ampere did not know that the copper wire was made of atoms. He did not know that the atoms contained electrons and protons and neutrons and neutrinos and photons. None of that stuff was known. And what occurred is, as he moved his magnet around the wire, the magnetic field deflected away from the needle, the compass needle, deflected away from and towards the copper wire. As he moved it around, there were 4 different orientations for the needle. And this is well documented. If you go and examine the quote that I have here, there's a book that's been written by Dr. Andrea Aziz, and it's available on his website here at this location, which describes that experiment in detail. You can also go and examine it on Wikipedia or somewhere else. So we have a ignorance of the actual structure of the wire. We have an ignorance of the structure of the magnet. We have an ignorance of electricity in its basic behavior. Why was there a magnetic field? Why was there an electric field? Those things weren't well known at the time. They just observed them. And Ampere discovered, or came to the conclusion, that because the electric circuit is electrons in motion, or an electric field in motion, he made the assumption that the electron, or whatever was causing this electrical flow, was producing the magnetic field. It was an assumption. And the question we have to ask is that assumption correct? Can we prove that Ampere has made an assumption that can be validated by experiment? And I will claim to anybody who wishes to go against me that we can't. To prove that an electric field produces a magnetic field, we have to have a material. The material in this hand has got to be electric material with no magnetic features of any kind. Then I need a magnetic material which has no electric features of any kind. And if I can move my electric material and get a response in my magnetic field, then I've proven the assumption. What's our problem? We know of no matter anywhere. We can't make any matter anywhere that is purely electrical with no magnetic features and purely magnetic with no electric features. That matter does not exist. We haven't found it and we can't make it. In the 1940s, it was discovered that the electron had a dipolar magnetic field, and the same was true of the proton. it had a dipolar magnetic field. So what we have is matter that has an electric field structure and a magnetic dipole structure. And these two materials exist in these two features exist in all of matter. So moving an electron is going to produce an electric and a magnetic field response. And the same is true for a proton if we're talking about plasmas or ions in solution. So what's occurred in modern physics, in quantum, is that as they measured these features, they noticed an oscillation and came to the conclusion that the electrons and the protons were spinning, or should be spinning. And because it's a spinning electric field, then it's going to produce a magnetic field. Problem solved. We've now got proof. No, we haven't. We have one physical object that we know about, and it's called the photon. And if you examine Wikipedia's description of a photon, you will find that the electric and magnetic fields go from 0 to a maximum positive value to 0 to a maximum negative value back to 0. And in Ampere's assumption, if the electric field goes away, there can't be a magnetic field. So if we were to say Ampere's assumption is correct, the photon would only oscillate through one phase between 0, maximum 0, and then stop. Or it can go from 0 to minus maximum and stop. The photon proves that Ampere's assumption is incorrect. So the question here we have is our equations that describe electric and magnetic interaction, the electric field and magnetic field interactions, require that assumption of Ampere's to be correct. If it's wrong, as I'm claiming, then the third equation in Maxwell's equation set, the standard Maxwell equations written by Oliver Heaviside, is false, which means we need to change our mathematics. Our model's wrong, our mathematics wrong, and therefore we get the result, which is shown by experiment, that the Maxwell field equations, the four magical equations, do not apply under all circumstances. And that's an indication that our understanding of what's going on is wrong. And therefore, because we've got the wrong model, we've got the wrong maths. So the equation 3 has to be replaced with something more like Weber's mathematics for electrical interaction, where the two charges are accounted for. Now, in the case of the electrons, there's two electric charge particles that are interacting, and that is well documented if we go and examine Weber's explanation. What Weber did not do, which is unfortunate, was treat or create a similar set of equations to deal with the magnetic structure. And it wasn't known by Weber in 1846 that the electron and proton, which were not known to Weber even, had a dipole magnetic structure. So for the magnetic part of those mathematics, we need to deal with a double pole interaction mechanism where we've got two norths and two souths interacting between two particles. And until we do that mathematics, we're not going to get the correct explanation of how electric and magnetic interaction occurs. So the third equation in the Maxwell's equation set, I'm claiming, needs to have a treatment for just the electric to electric interaction and just the magnetic to magnetic interaction, which is more complex. When we do that, I predict that we will get a much better set of equations that explain electromagnetic interaction far more comprehensively and far more effectively in terms of getting a result than has previously been the case. Now, you can't hold Ampere guilty of making it wrong, and none of us can be claimed to be making it right. I'm just putting forward a solution, and I could be wrong. And it's not up to me to produce empirical evidence because I don't have the equipment. I don't have the millions of dollars that's going to be required to prove this. However, we do know from the data found since Ampere up to the modern time that this information is present, that this data exists, and we have a different way of describing how an electron and a proton can interact and the magnetic mechanisms that are involved, which we have ignored.
Well, there you have it, folks. Thank you for being here for the 2022 Electromagnetic Universe World Expo. See you on the next round with the next presenter.